Hi, this is Algebra 2, Lesson 1. We're going to talk about polygons, triangles, transversals, and proportional segments. We're starting on page 19. Poly means many in Greek, and gonon means angle. So a polygon is a simple, closed, flat geometric figure whose sides are straight lines. It has many angles. On page 19, we have some shapes. Okay? These are all polygons. These are not considered polygons because the angles cross each other here. This has a curve, and this is not a closed figure. So these are not polygons. These are a special kind of polygon. Let me move up. Okay, so these are polygons. These are special kinds of polygons. If it has an indentation, we call this a concave polygon. If it has an extrusion, so things stick out, it's called a convex polygon. A regular polygon has all equal angles and all equal sides. A square and an equilateral triangle are regular polygons. Polygons that are not regular polygons are called irregular polygons. The name of a polygon tells us how many sides it has. So on page 20, there's a nice little chart, and it tells you if it has 3 sides, it's a triangle. If it has 4 sides, it's a quadrilateral. If it has 5 sides, it's a pentagon. If it has 6 sides, it's a hexagon. If it has 7 sides, it's a heptagon. And then we have octagons, nonagons, decagons, undecagons, dodecagons. After that, you just call them n-gons. So it could be a 12-gon, or a 13-gon, a 37-gon. Adjacent or next to angles are called consecutive angles, or consecutive vertices. Vertices is plural of vertex, and a vertex is another word for a point, really, but in this case it's an angle. Adjacent sides are called consecutive sides. So here's a poorly drawn pentagon, obviously not a regular pentagon. So this side is adjacent or consecutive to this side. And this angle is adjacent or consecutive to this angle. The diagonal of a polygon is a line segment that connects 2 non-consecutive vertices. So if we drew a line from here to here, or a line from here to here, those are diagonals. Okay? Triangles. I'm going pretty fast because I'm expecting most of the stuff is review. If a triangle has a right angle, it's called a right triangle. If one angle is larger than 90 degrees, the angle is an obtuse triangle. If all of the angles are less than 90 degrees, the triangle is an acute triangle. The sum of the measure of 3 angles of any triangle is 180 degrees. The greatest angle is always opposite the longest side. The smallest angle is always opposite the shortest side. So if we look at this triangle, we can see that the angles are labeled as 70 degrees, 30 degrees, and 80 degrees. And we can tell from that information that C is the longest angle because C is the longest side because the 80 degrees angle is the largest and it is the opposite angle. Side A is going to be the shortest side because the 30-degree angle is the smallest and it's side A's opposite angle. Okay, if we look at this one, our side AB is 7 units long, side BC is 10 units long, and side AC is 9 units long. So we know that angle A is going to be the largest angle because it's opposite the largest side. Angle C is going to be the smallest angle because it is opposite the shortest side. In any triangle, the angles opposite sides of equal length have equal measures. The sides opposite angles of equal measures have equal lengths. So here we have a triangle. This angle is 60 degrees. This angle is 80 degrees. We can figure out, because we know that the sum of all angles is 180 degrees in any triangle, we can figure out that 60 plus 80 equals 140, and therefore angle C must be 40 degrees, because that's 180 minus 140. So angle C must be 40 degrees. Since all the angles are different, the lengths of all the sides are different. A triangle with no equal sides is called a scalene triangle. If we look at this triangle, the tick marks on the two sides of this triangle from EF and from DE mean that they have the same length. Since DE and EF are equal, that means angle D and angle F are also equal. This one has two tick marks instead of just one, so this is a different length. So E is also a different length from D and E. A triangle with two equal lengths is called an isosceles triangle. In Greek, iso means equal and skelos means leg. So it means it has equal legs. Okay? Here's another triangle. All three sides are equal, so all three angles are equal. If all three angles are equal, then the angles must be 60 degrees, because 60 times 3 is 180. This is an equilateral triangle. In Latin, equa means equal and lateral means side, so it's equal-sided. Okay, let's try some examples. Here we go. We have a triangle. This angle is 50 degrees. The top one is y degrees, and this one is x degrees. And they want us to find x and y. We can see that this side and this side are equal from the tick marks. If the angle opposite this side is 50 degrees, then the angle opposite this side has to also be 50 degrees. If the sides are equal, then their opposite angles have to be equal. So if this angle is 50 degrees, then x also equals 50 degrees. And the sum of the angles has to equal 180. So we have a 50 degree angle plus a 50 degree angle plus y, and that has to equal 180. If 100 plus y equals 180, then y equals 80 degrees. Okay? Okay, let's try this one. We need to find x degrees and y degrees again. We have a triangle. This angle is 40 degrees. We don't have any tick marks, so we can't say that any of the angles are different. But what we do have is an outside angle here that's 150 degrees. And if you notice, this angle plus the x degree angle is a straight angle. That means 150 plus x has to equal 180 degrees. So 150 plus x equals 180, and therefore x equals 30 degrees. And now we can find y, because if x equals 30 and this angle equals 40, then y is going to have to equal 180 minus 30 minus 40. Because 30 plus 40 plus y equals 180. So 70 plus y equals 180. So y equals 110 degrees. Okay? Here's another example. This triangle is an equilateral triangle. So find d degrees. Remember, any equilateral triangle, if it has the same lengths of sides, the the angles all have to be equal also. So that means the interior angles here are all 60 degrees. D is an exterior angle going with C. And C plus D is going to equal 180 degrees because they make a straight angle. And C is 60. So D plus 60 equals 180. And therefore D equals 120 degrees. Okay? I told you to look for those outside angles. We're going to be seeing those a lot. Okay, changing gears a little bit, we're going to talk about transversals. A transversal is a line that cuts or intersects two or more other lines. So here are two lines and a line cutting across both of them. So this is a transversal. If a transversal intersects two or more lines that are parallel, and if the transversal is perpendicular to one of the parallel lines, then it's perpendicular to all of the parallel lines. So if they tell you that there is line S and line M and line N, and they are parallel, these two vertical lines here means parallel. So S is parallel to M, which is parallel to N. And if they tell you that P is perpendicular to S, and this is the sign for perpendicular. P is perpendicular to S. If P is perpendicular to S, then P is also perpendicular to M and N, because S, M, and N are all parallel. Okay? In this case, we have line L and line M. They are not parallel. That means not parallel. T is a transversal of L and M, but it is not perpendicular to either of them. Opposite angles are equal, and a transversal that intersects parallel lines intersects them at the same slope. So the angles made are going to be the same. So if these two lines are parallel, and they would be if they were straight, but I didn't use a straight edge, so they're a little curvy. We're going to pretend they're parallel. So if these two lines are parallel, and this line is a transversal of both of them, then it has the same slope when it passes this line as it has when it passes this line, and therefore it's making angles of equal degrees. So this angle, we're going to call it L, is equal to this angle. And this angle, we're going to call it S, is equal to this angle. Okay? As long as the lines they pass are parallel, transversals are going to make equal angles. Notice that the L and the S together go back to our straight line. So L plus S is always going to equal 180 degrees. Okay, let's try an example. If M is parallel to N, so M is parallel to N, find the degree of angle A, the degree of angle B, and the degree of angle C. Okay, so here's M, here's N. Here's a line that transverses both of them. This angle is 60. If this angle is 60, then this angle is also going to be 60. Okay? Opposite angles are equal. So if this angle is 60, then this angle is also 60, which means this angle is also 60. So C is going to be 60 degrees. This 60-degree angle and A added together make the straight line. So they're supplementary. So C plus A equals 180 degrees. And C equals 60. So 60 plus A equals 180 degrees. 180 minus 60 is 120. So A equals 120 degrees. Okay, now we just need to find B. if A is 120 degrees, then B is also 120 degrees. So B is also 120 degrees. Okay? Let me back up just one spot to here. I said opposite angles were equal and that I didn't actually show you. If this is L, then this is also L. If this is L, this opposite angle is also L. If this is S degrees, then this is also S degrees. If this is S degrees, then this is also S degrees. As long as these two lines are parallel, these opposite angles are going to be the same. Okay? So if this is 60 degrees, then this is also 60 degrees. If this is 60 degrees, this is 60 degrees because it's hitting both of these lines at the same slope. So it's making them both the same angle as it meets. So if this is 60 degrees, this is 60 degrees. And because opposite angles are the same, this is also 60 degrees. Okay? So that's how we figure this out. Okay, that was talking about the angles that are formed. Now we're going to talk about the lengths of the segments between the lines. When three or more parallel lines are intersected by two transversals, the length of the corresponding segments of the transversals are proportional. So we're talking about this length right here, from this line to this line. The length of this and the length of this are going to be proportional to the lengths of this transversal because they're passing through the same sets of lines. They're not going to be equal necessarily because the slopes are different, so they're coming in at different angles. The length of this transversal is not going to be the same as this transversal, but this segment, these segments are going to be proportional to these segments. So let me explain what I mean. So the lengths of the segments of one transversal are related to the lengths of the corresponding segments of the other transversal by a number called the scale factor. Okay, so if we say that this is 2 centimeters and this is 3 centimeters and this is 3 centimeters and this is 9/2 of a centimeter, 9/2 centimeters, and P is parallel with M, which is parallel to N, then define the scale factor from the left to the right. We're going to set it up like this. So 2 times the scale factor from the left to the right equals 3. Okay? We can solve for the scale factor by dividing by 2. The scale factor equals 3/2. Now, we should be able to say that this length times the scale factor equals this. So 3 times the scale factor, which is 3/2, should equal 9/2. And in fact, it does. Okay? We can also do this going from this side to this side. So 3 times the scale factor, and we're going to show the direction that we're going with the direction of the arrow. So 3 times the scale factor from the right to the left equals 2. Divided by 3, and the scale factor from the right to the left equals 2/3. So 9/2 times the scale factor from the right to the left should equal 3. 9/2 times 2/3. These 2's cancel and we get 9 divided by 3, which does indeed equal 3. Okay, that's how it works. Now let's try an example. Okay, here we have some lines. Your book is sometimes going to use these little arrowheads to show that lines are parallel. So this is just the same as saying this line is parallel to this line, which is parallel to this line. Okay? So the length of this portion of segment of transversal is 2. The length of this portion of transversal is 5. The length of this is 8/3. I'm not sure you can read my handwriting there. And the length of this is x, and we want to find x. Okay? We can do this either from the right to the left or left to the right. Since this is on the right, it makes more sense to go from the left to the right. So we can say that 2 times the scale factor from the left to the right equals 8/3. And now we're going to solve for the scale factor. So we're going to divide by 2. And the scale factor is going to equal, the 2 cancels, this becomes a 4, and we have 4/3. Okay? If 2 times 4/3 equals 8/3, then 5 times 4/3 has to equal x. So 5 times 4/3 equals x. And this is going to be 5 times 4 is 20 divided by 3, so x equals 20/3. We're just going to leave it in that form like that. And in this case, it didn't give us centimeters or meters or feet or inches, so we're just going to leave it with no units because the book didn't give us any units. Okay? That is it for this lesson. Let me know if you have any questions, try the practice problems, and do your homework. Thank you very much.